Okay, so today what we're doing is we're getting into solving quadratic functions. So we've already kind of talked about factoring. So today is kind of like, what's the purpose of factoring? Well, the purpose of factoring is it's one way to solve a quadratic. So a quadratic is always going to be in this form. This is called standard form. And notice that I added a equals 0 now, because we're going to take an expression and now make it an equation by setting it equal to 0 and solving. Okay, it needs to be in this format, so it has to be in standard form in order to factor first, and then we're going to take it one step further to solve. Okay, now this little 2 means that there are going to be usually 2 solutions. Okay, but when we're looking at a quadratic, this is what it's going to do. It's going to create what's called a parabola, and that parabola is going to have a certain amount of solutions or roots or x-intercepts. So there's a bunch of words that are interchangeable. So you might see something that says find the roots of this equation. They might say find the x-intercepts of this equation. They might say find the solution or solutions to this equation, or they might say find the zeros. And zeros just mean find where your y is 0, what is your x value. Okay, so these are all interchangeable. They all mean the same thing. Okay, so we could have 2 solutions like we have here. So this is a parabola that represents 2 solutions. We're also going to see that sometimes they might have 1 solution. And sometimes they might be something like this, where they have no solution. Okay, or no, I should say no real solution. And in Algebra 1, we usually said no real solution. But now in Algebra 2, we're going to find out that there actually are solutions, but they are what's called imaginary solutions. Okay? Is that the Ring app? All right, so these are the 3 different possibilities that we will see. And we'll get to more in depth of like, how do we know these are the type of solutions we're going to find? Today, what we're going to focus on is just factoring some more, and then now taking it one step further to finding out what are the solutions if I were to factor. Okay, so here are our steps. Step number 1 means we're going to have to factor. So same thing as what we did before. So ax squared plus bx plus c, we need to get into standard form. Okay, and in number 1, or A, we already have it in standard form. So I'm going to go ahead. What times what gives me x squared? So that's x and x. What times what gives me 6? It's either 1 and 6 or 2 and 3. Okay, now I've got to get to a -5 when I add. So that's kind of going to help us out a little bit, because either one could be to get to 5, but we have to get a +6. So it's either going to be 2 negatives or 2 positives. So what do you guys think? What numbers do you think we're going to have to use? Yeah, 2 and 3. And both of them will be negative. Negative times a negative gives me a +6. Negative plus a negative, so -3x plus a -2x gives me a -6x. Okay? So here are my factors. X minus 2 and x minus 3 equals 0. Okay? So we set them equal to 0. So we basically changed this expression to its factored form and kept it equal to 0. Now what we're going to do is step number 2 is to set each factor equal to 0. And then the third thing we're going to do is solve. So however many variables you see is how many solutions you're going to have. Okay, so in this case, we've got these 2 here, 1, 2. So x minus 2 equals 0, and x minus 3 equals 0. So we would add 2 to solve, so x equals 2 here. and add 3 to solve. So x equals 3. So x equals 2 and x equals 3. So the first thing we want to talk about is how do we write this as our answer? So we're going to do two little like squiggly lines. They're brackets. So they're not, we don't want to do this. This is not okay. This is our solution set. That means that those two are answers on the parabola. So if we were to think visually what this would look like, we'd go 1, 2, 3, and so our parabola is going to look something like this. I don't know exactly what it's going to look like yet, but I do know that it goes through at +2 and +3 on the x-axis. Okay, and that's all we need to know for right now. All right, so let's look at B. So notice that B, we got to start out with that, getting it into standard form. So I'm going to do 4x squared minus 25 equals 0. So how do you guys think we need to factor this one? Yeah, Owen?
Divide by the square root of this?
So you got to get the square root and the square root. It's a perfect square minus a perfect square. So 2x minus 5 and 2x plus 5. Okay, and then now we're going to solve. So 2x minus 5 equals 0, and 2x plus 5 equals 0. So I'm solving for x. Now notice that the only difference between these two is positive and negative. So we could really say 5 halves and negative 5 halves without having to solve both of them. You'll also probably start to see a pattern. So notice that your factors were -2 and -3. Your solutions were +2 and +3. Here your factors were negative and positive. Your answers are negative and positive. You just have to be careful with these when you have a variable, or sorry, a coefficient in front of your variable. You have to divide that out. So like this one, you have to divide by 2. This one here, you have to divide by 2. Okay, so I would like you guys to try and work on C and D. C is a little tricky because you've got a 12 here. So your options are 1 and 12, 2 and 6, 3 and 4. I'll give you a hint that it's 3 and 4. How about that? And I forgot, you have to move over that 2. So it's really a -2 there. Okay, so I'm getting 2/3 and -1/4 for C. Remind me to show you also how to do this in Delta Math, because I think you have to do like a little plus button, and allows you to add an extra answer. Okay, so looking at D, sorry, are there any questions about C? Are we okay with C? The hardest thing for that one, I think, was the factoring in the beginning, because like I tried it last period, and I was starting with 6 and 2, and then that didn't work, and then I had to go to 3 and 4. So looking at this one then, if we move over the 6x, it should be 5x minus 5x squared, sorry, minus 6x equals 0. So this is a binomial, so we're not going to do our x. It's a binomial, so it's either GCF, perfect square, or perfect cube. So what do you guys think? What can we do here? GCF, perfect square, or perfect cube? GCF, yes. A GCF of x, so we're left with 5x minus 6 equals 0. Okay. Again, whenever you set each factor equal to 0. This is a factor. This is a GCF. So we said x equals 0 then, and 5x minus 6 would also equal 0. And then we'd solve. Well, in this case, since there's no number in front of it, we don't have to do anything. So that's already solved. And this one, we would add 6 and then divide by 5. So we get 0 and 6/5. Okay, so that's it for our notes today. So it was a pretty quick lesson. Now what we're going to do is just practice. Yes?
Do we put the X on the outside of that?
No, you don't put, so the x, you don't want x to equal 0 here, or x would equal 0 here for the solution here.
Okay.
So that's why you have the 0 there. That represents the solution for x. Okay? So now what we're going to do is we're going to go to the